Find the domain and range of the function fx equals the square root of x minus 3. Okay, what's the domain of this function? What is a domain? Tell me what's a domain. All the inputs, all the x values that can be plugged in. Okay. Can you plug in 0?
Would it be bracket 3, comma, infinity?
Yeah, that's correct, yeah. You can't plug in 0 because it will make negative 3 inside the square root. So 0 is no good, 1 is no good, 2 is no good. 3 is okay, because if you plug in 3, 3 minus 3 is 0. What is square root of 0? 0. Okay, square root of 0 is 0. So 3 is okay. 3 is a valid input. You can plug in 3 and you can get an output. Therefore, 3 is okay. And anything above 3 is okay as well. You can plug in 4. 4 minus 3 is 1. Square root of 1 is 1. So you can plug in any number that you want. So that tells us that the domain should be 3 to infinity. Because anything under 3 is going to make the square root, the inside of the square root as a negative, and that means you can't calculate the function. Okay, what about the range? Range is what? What's the meaning of the range? All the y values, okay? So all the outputs. Now, can this produce 0? Yes, it can, right? If you plug in 3, we got 0. We just said that, right? Can it produce anything negative? No, square roots only produce positive numbers, right? Square roots never give you negative numbers. The meaning of the square root is it's a number that squares to 4, or let's say 9. What's the meaning of square root of 9? The number that squares to 9, which is positive. It's in the definition that it should only produce positive numbers. And the only time it gives you something that's not positive is when you plug in 0. Square root of 0 is 0. So it never produces negatives. So the lowest this can have is 0. Now, how high can the output become? Infinity, because you can plug in a very big value. If you plug in something like 1,000,000, square root of 1,000,000 is 1,000. So if you plug into 1,000,000, then you get a value close to 1,000. Okay? And if you plug in 1,000,000,000,000, you get a value close to 1,000,000,000, and so on and so on. You can plug in some really large value to make the output as large as well. So that means infinity is another possible outcome. So that's just by inspection and just thinking about the fact that domain is the x value that you plug in and range is the y value that the function will give you back. But that doesn't seem so systematic, so let me show you a different approach to the same question. So another way to do this is to draw the graph. We want to draw the graph of y equals to square root of x minus 3. But in order to draw that graph, you should think about the graph where minus 3 is not there. But that's a simpler one. And in fact, this is one of the graphs that you should memorize. What's the graph of y equals to square root of x? Can you draw it in the air? What's the graph of square root of x? Like that. Right? It's this one. You have to remember this. We did this graph before. Do you remember? No? Should I do this again? You remember? Okay, okay, all right. Okay, now, so this is something that you should memorize. Square root of x has this graph. You have to memorize it. Now, once you have this graph, what does this do? What does this minus 3 do to the graph? Makes it move. Move in which direction? 3 to the right. So if you replace x by x minus 3, the graph moves 1, 2, 3 right, and now you have this. That's the graph. Now, if you know that's the graph, actually it just keeps increasing. Like that. If you know that that's the graph, then now it's easy to see what the domain and range are, because for every point on the graph, you have the x value and the y value, and we're looking at the x value for the domain and the y value for the range. Let's look at the x values. Because we move 3 steps to the right, this point is 3, right? So you can see that the x values start from 3, and you can keep going right. As you go right, you get all the numbers after 3. Is that clear? So that's why the domain is 3 to infinity just from the graph. Okay. And now let's look at the y values. As you move on this curve, the y values are the height, right? Now, what's the lowest height that the point on the graph can have? 0. It's right when it's on the x-axis, the height is 0. If you're on the x-axis, height is 0, right? And then you go up. Now, is there a limit to going up? Well, the growth kind of tempers down, but it still managed to go to infinity. That's the nature of this graph. So it starts from 0, and then it keeps going up. It can go up, and there's no upper bound. So that's why the range is 0 to infinity. All right? Okay. A farmer with 2,400 meters of fencing wants to enclose a rectangular field that borders on a straight river. If the farmer does not fence the river side, what is the largest area that can be enclosed? Now let's try to draw a picture to help us understand what's going on. Here's a straight river, and the farmer is trying to enclose a rectangular region like this. And the goal is to make the area as big as possible. Okay. And that's the question. So this is a rectangular kind of question. In the previous exam, exam 1, you had similar kind of questions in the practice exam, right? These geometry problems where we were talking about the perimeter and all that, right? So in the basic approach to this question is very similar to that. You just draw the graph, label the sides, and see what the question is telling us about the sides. So let's call this side as x. Let's call this side as y. All right. And we see this number 2,400 meters. Now, what should I do with 2,400 meters? 2,400 meters is the fence that you're using, right? You don't have to block this side. You're only trying to fence this much, right? So 2,400 equals to what, according to this graph, this picture? No, x times y gives you what? Area. Okay, that's not what we want. You want that this length is 2,400. So what's the equation for that? 2,400 is 2y plus x, right? It's y plus x plus another set of y. So you have 2 y's and an x. That has to be equal to 2,400. Okay? And what are you trying to maximize? You want the largest area. And you already told me the area formula. What's the area? X times y. Okay. Now, if you have more than one variable, you should solve for one of the variables and plug it into the next one. Although, in many cases, I said, oh, it's easier to solve for x. I think for this case, we'll solve for y. Okay, so let's subtract x to the other side so that you have 2y equals to 2,400 minus x. Divided by 2, so it's 1,200 minus 1/2 x. Okay, 1,200 minus 1/2 x is your is what you get if you solve y as a function of x. And then that's going to be plugged into this y so that you have the area as x times 1200 minus 1/2 x. Now let's multiply this together, so you get negative 1/2 x squared, and then x times 1200 will be 1200x. And I kind of reverse the order. I like the square coming before the first power, so I'm going to write it this way. Okay. So we've expressed area as a, what kind of function is this? If it is x squared, a polynomial that whose highest term is x squared is called a quadratic function. Okay, so this is a quadratic function. And what's being asked? I want the largest area. Oh, so this is a quadratic function problem, finding the maximum. I know how, when a quadratic function hits its maximum. When does it hit the maximum? Yeah? At the vertex, right? Especially because x squared has a negative coefficient. Polynomials, quadratic functions with negative coefficient opens down, right? Here's the vertex, it opens down. So the vertex becomes the highest point. That's what we're trying to look for. Okay? Once you get to this point, then you've already taken a quiz on this, right? So you probably know what to do. How do you find the vertex? H is negative b over 2a, which is negative 1200 over 2 times negative 1/2, right? Yes? Okay. Now, is this positive or negative? It's positive because this minus and this minus cancels. If you have some number on top, some number on the bottom, they cancel, right? Yeah. So these two minuses cancel each other. What's 2 times 1/2? If you multiply any number by its reciprocal, you get 1. So you end up with 1200 divided by 1, which is just 1200. Okay, so you got the h. How do you get the k? Yeah? Plug in the h into the function. So k is going to be this function. We'll call this function f of x. F evaluate at 1200, which is negative 1/2 1200 squared. And you have to be mindful of the order of operations here. This is squared first, and then you multiply 1/2, right? And then plus 1200 times 1200, because we're plugging in 1200 into x. That's what you have. I think the second one's easier to calculate. What's 12 times 12? 144, right? So then you have 0, 0, 0, 0. So the second number is 144, 0, 0, 0, 0. Oh, wait, but 1200 squared is same thing as 1200 times 1200. So this will be negative half of this thing because there's a half in front. What's half of this? 720,000, right? And the result is that you get 720,000 square meters as the maximum area. Okay, right? Because this is the maximum area, right? Yeah. That's your area, and you actually gain some more insights to this because see when x is this 1200, you get the maximum area, right? So we see that this length should be 1200 meters. And then this plus this should be, well, what's 2400 minus 1200? It's 1200, right? So this plus this should be the remaining fence, which is 1200. And that means half of it would be y. So this must be 600. So not only solving it this way will tell you what the maximum possible area that the farmer can enclose could be, it also tells you what should be the length of each side so that you can have the maximum area enclosed. Now, if you are trying to raise cattle or something in a wide open land, maybe this is a pretty important question to solve, right? You want to just use 2,400 meters of fencing, but you want to enclose as much as possible so that even when your cattle are in the fence, inside the fence, they still have something to chew on, right? So, yeah. One last remark is sometimes these types of questions would ask you the maximum area, in which case this will be the answer. But sometimes it might ask what should be the dimension of the field enclosed so that it has the maximum area. In that case, 1,200 and 600 would be the maximum area. All right? Here we have 4 lines, A, B, C, D. And the question is, which line has the slope of least value? Yes. You're spoiling the... That's a spoiler. Okay, yeah. Don't spoil the... Okay. All right, we need to chew on this a little bit to understand. Yeah. Okay. All right, so let's think a little bit. So here's C. Can you put a number that's something like a slope of C? Something, yeah. 3 would be a good number, right? So we know that if the slope is this way, exactly 45 degrees, then the slope is 1, right? And then as it gets steeper and steeper, it gives you a bigger number, right? So since it's above 1, anything above 1 would be a good placeholder for some kind of slope for this. So let's just say this slope is kind of like 3. But if you said 2 or 4, I would still say you're right. Okay, we don't know for sure. It's something bigger than 1. Okay. All right. What about this D? Well, this is slightly less than 45 degrees, so the value of the slope of the D is more like what? 1/2, right? Yeah. So anything less than 1. So if you did like 2/3 or 1/4 even, all of these could be a nice number to state. So a representative number for this slope is like 3. This would be like 1/2. Okay. What about this A? It's negative, right? It's falling down. It's decreasing. So you have to know that any line that's increasing should have a positive slope, right? Increasing, decreasing is read from left to right. You know that, right? Just like how you read the stock market. Yeah. If you have a stock market that goes like this, you don't say it's decreasing. You still read from left to right, right? So if it's like this, you say it's increasing. Yeah. Okay. So if you have an increasing graph, slope is positive. If you have a decreasing graph, the slope is negative. All right? Okay, so now back to this one. If A is, so we know that A is negative, but it's also not that steep, right? So the absolute value of the slope is bigger than 1 or less than 1? Less than 1. So give me a number. Negative 1/2 will be like a nice estimate of this slope. If you said negative 2/3 or negative 1/4 or negative 1 over anything, I probably would accept it as true. Okay, then what about this B? It's negative, right? And it's steeper than the 45-degree one, so it's negative 2, negative 3, anything like that, okay? So let's say negative 2. Okay, if these are the values, among these values, which is the lowest? B. So the answer is indeed correct. Yeah. B is correct. Yeah. Okay, let's look at this next question. Find the slope of the line below. Here's a line. And how do you find the slope? What's the formula? No, the slope formula. Yes? Change of, yeah, right. Change of y over change of x. So slope is change of y over change of x. And when you're given a picture, often rise over run is a better way to see it. Okay? Yeah. Yes. That's fine. Yeah, I like this because this is friendlier to calculus. You guys are taking this pre-calculus class, so I like to write it this way. But the change of y means it's the final value of y minus the initial value of y, right? Yeah. Same thing here. This is x2 minus x1. So this formula really means y2 minus y1 over x2 minus x1. That's what it means when you actually use it in practice. Yeah. But I'm telling you that rise over run is a better way to do stuff when you're presented with the picture. Okay, so let's think about that. We look at 2 points from this point to this point, and we look at its rise and run. Okay, so what is the rise as you go from here to there? It's negative. It's going down, so it's negative. Negative what? 1, 2, 3. So the rise is negative 3. What's the run? 1, 2. Okay, so run is 2. A rise over run, therefore, what's the slope? Negative 3 over 2, okay? Which is the same as negative of 3 over 2. Okay? So the slope is negative 3 over 2. Which of the 4 equations should give you this as the picture? Yes?
Y equals x squared.
Yeah, y equals x squared, right? Which of the 4 equations is this one? X cubed. How about this one? Absolute value of x. Okay. And this one?
Y equals square root of x.
Okay. So these are graphs that you must memorize. Okay. Of course, if you forgot it, then you can plug in values to see what the graph will look like, but it's definitely something that you have to memorize. You have to memorize the graphs. (23) says, I have to draw the graph of y equals to absolute value of x minus 1. Right? That's what it says. Now, when you're asked to draw a graph, it's important to think about the prototype of the function, which is like the function before it was transformed. So if you get rid of all these numbers, you get the original function that you had. So this comes from y equals to absolute value of x, right? But what's the graph of y equals to absolute value of x? The V-shaped graph, right? And now the question is, would this minus 1 move it left, right, up, or down? Which one is it? Okay, how many of you say right? How many of you say left? How many of you say up? How many of you say down? Okay, so we have a few people saying down and some people saying right. Here's one way to think about it. If you plug in 0, what do you get? Negative 1. If you plug in 0, absolute value of... Oh, this is for the previous question. You shouldn't be looking at this. Okay, so if you plug in 0, you get negative 1. Do you agree? Right. So already that's a hint. For this to somehow pass through this, should it move right or left or up or down? What? Down. Down. It has to go down. And you can do a few more. If you plug in 1, you get 0. If you plug in negative 1, you get 0 as well. So that's what you get. Okay, 24, you have y equals to negative square root of negative x. Now, before you draw this graph, let's think about the domain of this function. Can you plug in 1 into this function? No, no, because minus is outside and then you have negative 1. If you plug in, so if you plug in x equals to 1, that's going to make you negative square root of negative 1. But square root of negative 1 is not a real value. In pre-calculus, we only deal with real valued functions, right? So 1 is no good. What value can you plug in? Negative 1 is fine. Can you plug in 0? Yeah, square root of 0 is 0, so that's okay. Okay, so what's the domain of this function then? All the negative numbers, right? And 0. That's the domain. Yeah, all the negative values and 0. Okay? So you have on the x and y, you only have values on this side. Is that good? All right. Now, what would you get if you plugged in negative 1? Do you get positive 1 or negative 1? You get negative 1 because of this negative, right? So let's try it. If you plug in negative 1 into x, you get negative of square root of 1, which is negative 1, right? So if at negative 1, it's negative 1. So that's what you get, right? And at 0, it's 0. Oh, okay, so that kind of gives you some idea, right? What is the prototype of this? That's when none of these minuses appear. That the prototype for this one is y equals to square root of x. Do you remember the graph? It's this one, right? So this one is, well, negatives, they reflect. So this is reflected in some direction. To pass through these 2 points, what can it be? It has to be this one, right? So that's like one way to do it without really thinking of transformations, but let's do it a slightly different way. Okay, we start with y equals to square root of x, which by now everyone remembers, right? And then think about what happens if you put a minus in front of y equals to square root of x. It reflects over where? Y-axis or x-axis? It flips upside down, right? And you can just check by plugging in some numbers. You know that it should flip upside down. So it's like this. And then if you put minus of negative x, what does this do? This one will flip it over the y-axis. So this is what you get. Okay. Now, if this is confusing, here's a way to figure this out easily. You want to put the axis x and then y here, and then put negative y and negative x here, okay? And instead of writing this, multiply the negative 1 both sides, so rewrite it as negative y equals square root of x. These two are the same thing, right? Now, what's happening from here to there? Everything is exactly the same except that y is replaced by negative y, okay? So in this picture, if y is replaced by negative y, what's happening? This is happening, right? You're doing this. So it flips upside down. Is that good? All right. Now, from here to there, what's happening? X is replaced by negative x. So in this picture, what's happening? X and negative x are flipped, right? So it's flipping over the y-axis. That's what's happening, right? Flipping over the y-axis. Okay. Now, you could have gone this way as well. You could also first think about y equals the square root of negative x. What's the graph of this? If you went from x to negative x, what is that? X and negative x? Yeah. Not the second quadrant, right? That's called second quadrant. What you're drawing is second quadrant, okay? It's 1, 2, 3, 4. This side is second quadrant.
That's second?
Yeah, that's second quadrant. Yeah, you go 1, 2, 3, 4. Okay, 1, 2, 3, 4. This is second quadrant. Okay. All right, so what's happening is that x and negative x flips, right? So they change, and therefore you're taking that picture and flipping this way, which is like reflection over the y-axis. And the resulting graph is that you get a graph in the second quadrant. And then you put minus in front. What does this minus in front do? It flips over the x-axis. Okay? So you get this. Find the remainder of 2x cubed minus 3x squared minus 3x plus 2 divided by x minus 2. This is a division problem. And you just have to divide using the long division. Now, some of you asked me if you can use synthetic division. That's fine. Okay, you can use synthetic division if you know how to do it. But I don't have the time to treat the synthetic division fully, so you will have to teach yourself if you want to use it. It does make the calculation easier, and you will make less errors if you know how to use it. But learning it will take some time, and getting used to it will also take time. All right, so how do you do the long division? Well, the long division idea is just two things. One is that the number that you place here should be something that multiplies the leading term so that these two are the same. These two must be the same, okay? So that's the first idea. That's the choice of this is such that this times this is equal to this. Okay? Now, the second idea is that once you choose this, this has to be multiplied to every one of both of the terms, and you have to subtract. Okay? So those are the two things that you should do. Let's ask the first question. X times what gives you 2x cubed? X times what? 2x squared, yes. You multiply x by 2x squared. X times 2x squared gives you 2x cubed. But wait, then this has to be multiplied to negative 2 as well. What's 2x squared times negative 2? Negative 4x squared, right? Right? 2x squared times negative 2, it'll be a negative, and 2 times 2 is 4, and you have x squared. Now, once you have that, you have to subtract. Now, how do you do the subtraction? Well, it's negative 3x squared minus negative 4x squared. Right? First of all, 2x cubed minus 2x cubed is anything minus itself is 0, right? Yeah. Anything minus itself is 0. Next, negative 3x squared minus negative 4x squared. What's that? Negative 3x squared plus 4x squared, right? Which is x squared. Okay? So this is going to be x squared. And then you bring the other ones down, negative 3x, and then plus 2. Okay. Now the leading term is x squared. So you go try to find this missing thing again. What times x gives you x squared? X, right? So you put plus x. X times x is x squared. X times negative 2 is negative 2x. Subtract. Again, x squared minus x squared is 0. Let's think about this. What's negative 3 minus negative 2? That's negative 3 plus 2. Isn't that right? If you subtract the negative number, that's same as plus. So you have negative 3 plus 2. That is negative 1. Negative 1, not positive 1. So you have negative x plus 2. Okay, finally, x times what gives you negative x? Negative 1. So you put negative 1, and you have negative x plus 2. Well, negative 1 times negative 2 is positive 2. So that's where you get the plus 2. And if you subtract, you get 0. And this is your remainder. Remainder is 0. Okay. So the answer to the first part is 0. Let's look at the second question, though. The second question says, factor this cubic. And in many math problems where it's divided into A, B, C, D, E, many times you use the previous result to help with the next one. See, if you look at what this happened was, if you look at what we just calculated is that if you divide 2x cubed minus 3x squared minus 3x plus 2 by, you divide it by x minus 2. What's the result? What do you get as a result if you do this division?
I mean, no, 2x squared.
2x squared plus x minus 1, right? So that means if you multiply the x minus 2 to the other side, you get 2x cubed minus 3x squared minus 3x plus 2 is equal to x minus 2 times 2x squared plus x minus 1. Oh, that's nice because this is factoring. What's factoring? You represent one thing by a product of a bunch of other things. That's factoring. However, you shouldn't end here because you have to factor this further. This can be further factored. Okay? How do you factor 2x squared plus x minus 1? Can you factor 2x squared plus x minus 1? How do you do that? AC method? Anyone? 2 times negative 1 is? Negative 2. Middle number is 1. So you're looking for two numbers that multiply to negative 2, add up to 1. What is it? Right, so this is going to be 2x squared plus, it's 2 and negative 1, so you split the middle x as 2x and minus x. That's how we learn to factor these kind of things, right? Which now becomes 2x times x plus 1 minus x plus 1. Okay? And the result is that you have 2x minus 1 times x plus 1. Okay, so that we now know that this factors as x minus 2 times 2x minus 1 times x plus 1. That's going to be the answer to the second one. The factor is x minus 2 times 2x minus 1 times x plus 1. Now, let me introduce another method to factor this. Because, although we've done X charts so many times, some of you are still not there yet. You still can't do it alone. Or some of you just learned it for the exam and then already forgot. Yeah, it's happening over and over again, right? But unfortunately, in math, we expect that you remember everything you learned. Yeah. It's kind of unreasonable, but that's math builds on top of the previous knowledge, so we can't avoid it, right? So let me try to propose a slightly different method for this one. If you have a polynomial, any polynomial, by the way, then you can look at this last number. Think about all the factors of that number. Negative 1 has factors 1 and negative 1, right? Negative 1 times 1 is negative 1, so negative 1 and 1 are the factors. Then what you want to do is you just want to plug in those values to the function itself and see if you get a 0. If you get a 0, then you're in game. You can start applying this method. If you don't get 0 for any one of them, then sorry, it's not going to help. But many times it does work. So here's what you have. See, f of x, you set this equal to 2x squared plus x minus 1. Let's plug in 1. What do you get? You get 2 plus 1 minus 1. Is that right? 1 squared is 1, times 2 is 2, 1, and then minus 1. What's the value? What do you get? 2. Okay, So that's not 0. That's no good. What if you plug in -1? 2 times -1 squared plus -1 minus 1. -1 squares to +1, so it's 2. -1, -1, that's minus 2. So that's going to be 0, right? Oh, that's great. Now we can apply something. If you have f of something equal to 0, we have something called the factor theorem. What does the factor theorem say? Yeah?
Two things multiplied together equals.
No. You keep talking about the factor property. No, you said that this last time as well. What's the factor theorem? If something, f of something equal to 0, then something is a factor. What's the factor? Yeah. So factor theorem is that if you have f of a equals to 0, then x minus a is a factor. A very important theorem. You should know this, okay? All right. So, look, we got f of -1 equal to 0. What does that mean? What is a factor? The factor theorem says that x minus what? X minus -1. Look, a is -1. We just plugged in -1 and you got 0. So a is -1, okay? So x minus -1 is a what? A factor of what? Factor of 2x squared plus x minus 1. That's what it is, right? And then x minus -1 is x plus 1, right? So that immediately says that 2x squared plus x minus 1 is equal to x plus 1 times something. Because that's what factors mean, isn't that right? Factor means it's a part of the product that makes up the whole thing. Right? That's what a factor is, right? It's like 6 is equal to 2 times 3. So 2 is a factor of 6. 3 is also a factor of 6, right? So knowing that x plus 1 is a factor immediately tells you that this is equal to this times something. And once you know one of the factors, it's not very hard to find the other one, because x times what gives you 2x squared? Tell me. X times what gives you 2x squared? 2x. That's the only thing that can be there, right? Now, 1 times what gives you -1? No. Oh, yes, -1. Yeah, right. Okay, 1 times -1 is -1. All right. So that's it. That's exactly the factor that we wrote down, right? It's x plus 1 times 2x minus 1. And the beautiful thing is that we didn't have to do the x chart. Okay. So if you forgot how to do the x chart, then you can use this thing, which is just plug in random values and see if you get a 0. Then if you get a 0, then the factor theorem says, oh, I know a factor. Then if you know a factor, the other one's almost given. Right? Okay. Now let's go for part C. Find the x and y intercepts. X-intercept is the places where the graph passes through the x-axis, and because all the y-coordinates of points on the x-axis is 0, right, yeah. And therefore, to get the x-intercept, what do? Set y equals to 0. Okay? Which means that in this graph, you set 0 equals to 2x cubed minus 3x squared minus 3x plus 2. But we already know that this is same thing as x minus 2 times 2x minus 1 times x plus 1. That has to equal to 0, and therefore, you can solve this by using the factor property that you love, right? What's the factor property? That it's that if you have multiple things multiplied to give you 0, then at least one of them has to be 0. So either x plus 2 is 0, x minus 2 is 0, which is that x must be 2, and 2x minus 1 is 0, which means that 2x is equal to 1, and then you divide by 2, which is 1/2, or x plus 1 equals to 0, so x is equal to negative 1. Okay, so those are the x-intercepts. How do you get the y-intercept? To get the y-intercept, what do you do? Yeah, set x equal to 0, right? Y-intercept, you set x as 0, and that means you're plugging a 0 into here. So it's 2 times 0 cubed minus 3 times 0 squared minus 3 times 0 plus 2, which is 2. Okay, great. So we know the x-intercepts and the y-intercepts. We're done with C. The last one, draw the graph. How do we draw the graph? Well, we know the points that it must pass through. So if I say this is 1, this is 2, this is negative 1, and then this is 2, we know that the y-intercept is 2, x-intercepts are 2, negative 1, and then 1/2. So we have 1, 2, 3, 4 points that the graph must pass through, right? And in addition, I know the general shape of a cubic curve. What's the general shape of a cubic curve? Yeah, it's like that, right? So you just have to do, that's the answer.